All right, so let's talk tangent lines. I already showed you, some examples on the Desmos. Okay, so I'm gonna look at these three graphs and I'm just gonna sketch a tangent line. So if our graph is increasing, then we have a positive slope. If our graph is decreasing, then our tangent line is going to have a negative slope. And then if the graph has a minimum or a maximum, then the slope is 0. All right, so we're going to try to figure out how to find the slope of a tangent line. So I'm going to draw a curve, and I'm going to pick a point that I want to find the tangent line of. So let's say this point here. Okay, I want to find the tangent line. So the tangent line is going to look something like that. I'm going to say this point is C, which makes its function value here f of C. If I want to find the slope of a line, I need 2 points. Okay, we can't find the slope of a line with just 1 point. So I'm going to pick another point here. Okay, and I'm going to draw the secant line. So here's my secant line. This would be my tangent line. Okay, well, I picked another point out here, and I'm going to call that x, f of x. Okay, so we can find the slope of the secant line. So m secant is going to be y2 minus y1 over x2 minus x1. So in this case, f of x minus f of c over x minus c. The idea behind a tangent line is I want this point to be as super close to this point as I can, because that's going to be the slope of the tangent line. So what we're going to do is we're going to bring this point to this point. So we're going to close the gap between x and c. The tool we have to do that is limits. So the slope of the tangent line is going to be the limit as x approaches c of f of x minus f of c all over x minus c. As that gap gets infinitely small, then we have the slope of the tangent line. So this is the definition that we're going to use to find the slope of a tangent line. So we're going to find the slope of the tangent line at a given point. All right, so we have f of x equals 3x squared minus 4x plus 1, and I'm interested in what is the slope of the tangent line when x is equal to 2. So the c in my definition, the c is the point, so my c in this case is going to be 2. So we want the limit as x goes to 2 of f of x minus f of 2 over x minus 2. Now this should seem familiar because you've done a bunch of these limits already. You just didn't know why you were doing the limits. Now you know what we're finding is the slope of the tangent line. So before I plug in my information, I'm going to come over here and find f of 2. is going to be 3 times 2 squared minus 4 times 2 plus 1, which is 5. Okay, so this is going to be the limit as x goes to 2 of f of x, which is this entire function, 3x squared minus 4x plus 1 minus 5. All over x minus 2. So then we'll simplify. So we have 3x squared minus 4x minus 4 over x minus 2. We can't just plug in 2 because we're going to get a 0 in the denominator, so we are going to have to factor. But again, this is easy factoring because we already know what one of the factors better be. It must be x minus 2. So I'm multiplying x minus 2 by something to get this. So to get a 3x squared, my first number needs to be a 3x. To get a negative 4, my last thing needs to be a positive 2. The x minus 2's cancel, so we're just left with the limit as x goes to 2 of 3x plus 2. Plug in 2. So my slope is 6 plus 2, or 8. So on this parabola, when x is equal to 2, the slope at that single point is 8. All right, so same question, new function, new point. Now I encourage you to try this one on your own, see if you can get the right answer. Okay. So we're going to have the limit as x goes to 1 of f of x minus f of 1 over x minus 1. So I need to find f of 1. So that's going to be negative 2 times 1 squared plus 3 times 1 minus 1. So we get negative 2 plus 3 is 1 minus 1 is 0. So we're going to have the limit as x goes to 1 of f of x minus 0. So it's just going to stay there. Okay, and then we're going to factor. So I know one of my factors is x minus 1, which means my other factor is going to be a negative 2x plus 1. So then we're looking at the limit as x goes to 1 of negative 2x plus 1, and then we can plug in 1. So this is going to be negative 2 times 1 plus 1, which is negative 1. Now we're going to take this a step further. We're going to find the equation of the tangent line at the point, and then we're going to graph both the function and the point. So we need to find, anytime we're trying to find the equation of a line, we need a point and the slope. So we have a point, 2, 1, and our slope we're going to find using our slope formula, our tangent line formula. So my slope is going to equal the limit as x goes to 2 of f of x minus f of 2 over x minus 2. So f of x is 3x squared minus 8x plus 5 minus f of 2, which is 1. We don't have to plug it in. We're just given that. So we have the limit as x goes to 2 of 3x squared minus 8x plus 4 then we will factor. So we have x minus 2, and then we look at what we need to multiply. To get that, I need a 3x. To get that, I need a negative 2. So we can take out the common factor, which leaves me with 3x minus 2. And then we plug in 2. So 3 times 2 minus 4, minus 2 is 4. But we're not done. We have to write the whole equation. I now have the slope. So I'm going to use the point slope equation, which is y minus y1 equals mx minus x1, to find the equation of the line. So my point is 2, 1, my slope is 4. So y minus 1 equals 4 x minus 2. So we get 4x minus 8. So y is equal to 4x minus 7. So this is the equation of the line at the point 2, 1. Then we're going to graph it, and I'm just going to graph it on the calculator to illustrate what exactly we have just found. So in the calculator, I put the given function, 3x squared minus 8x plus 5, and the equation of the tangent line. So when I graph, we're going to see the parabola. And we're going to see the tangent line. I'm going to go ahead and zoom in. About there is fine. So you can see it touches this point, 2, 1, and it just grazes it. So we found that slope using limits. Right, so let's do another one. So we have the function 2x squared plus 3x minus 1 at negative 1, negative 2. So my slope is equal to the limit as x goes to negative 1 of f of x minus f of negative 1 over x minus a negative 1. So this is going to be the limit as x goes to negative 1 of 2x squared plus 3x minus 1 minus a negative 2 all over x plus 1. So negative 1 plus 2 is a plus 1. Then we factor. So x plus 1 is one of the factors, which means 2x plus 1 is the other factor. So we have 2x plus 1. Plug in 1. So I plug in negative 1, and we're going to have 2 times negative 1 plus 1. So a negative 2 plus 1, we have a slope of negative 1. Now we're going to take that and plug it into the point slope form of a line. So we're going to have y plus 2 equals negative 1, x plus 1. So y plus 2 equals negative x minus 1. So y equals negative x minus 3. Again, we can graph it on the calculator to illustrate this, to see the parabola and the tangent line, to see what that actually looks like. Same question, but with a different type of graph. So the absolute value of x minus 2. So I'm actually going to use the graph of this one. So we know what absolute value looks like. This moves our graph to the right 2 units. So my graph looks like this. The tangent lines are going to match the slope of the graph. So if I go to 0, the tangent line is going to match that half of the graph. So it's actually just this line. So this is going to be y equals a negative x plus 2 for that part of the graph. When x is 4, we're here, which is this line, which is going to be y equals x minus 2 if you trail this back. At 2, when we have a curve, we can find the slope. But if it's an abrupt change, then we say that there's no slope there. So there's no tangent line at a corner. Okay, we're gonna find a second definition for finding the slope of a tangent line. So we're gonna illustrate this one. It's gonna be similar in its setup, but then it'll be a little bit different. So let's draw our curve again. And let's say I want the slope at this point here. I'm gonna call this x, which makes this f of x. I'm going to pick another point out here. And I'm going to say this distance is h. Okay, so here's my point. If this distance is h and this is x, that makes this x plus h, which makes this f of x plus h. Okay, for this definition, what I want to do, so I'm going to do this twice. We're going to first do the slope of the secant line. So the secant line is going to go through those two. So that's going to be f of x plus h minus f of x over x plus h minus x. Okay, that's going to simplify down. But I'm going to jump to the tangent line because that's really what we're interested in. So the tangent line is going to occur as this h gets infinitely small, as soon as this point is basically on top of this point. So again, we're going to use limits. So this is going to be the limit as h goes to 0, as that gets really, really small, of this whole thing. F of x plus h minus f of x over this x plus h minus x is just h. So we have the limit as h goes to 0 of f of x plus h minus f of x all over h. This is our second definition. And this one will find the slope at any point. And we'll do an example to illustrate that more. Okay, so we're going to find the slope at any point of 2x squared minus 5x plus 3. So we're going to use the definition that the slope, that the limit as h goes to 0 of f of x plus h minus f of x over h. So I'm going to evaluate this function at x plus h. So this is the limit as h goes to 0 of 2 x plus h squared minus 5 x plus h plus 3 minus f of x. So minus 2x squared minus 5x plus 3. All over h. So you've done problems like this. We're going to simplify this all down, and then stuff will start dropping out. Okay, so I'm going to FOIL this. So this is going to be x squared plus 2xh plus h squared minus 5x minus 5h plus 3 minus, I'm going to squeeze it in here, 2x squared minus 5x plus 3. Give myself a little bit more room there. All over h. So one more step. So we have 2x squared plus 4xh plus 2h squared minus 5x minus 5h plus 3 minus 2x squared plus 5x minus 3. And if you're having a hard time seeing it, just look at the PDF version of the notes. But we have a 2x squared minus 2x squared minus 5x plus 5x, and the 3 cancel. So we have 4xh plus 2h squared minus 5h is all that's left. Well, they all contain an h, which means we can now eliminate that. So that's going to leave me with 4x plus 2h minus 5. And as h goes to 0, that means I'm left with 4x minus 5. So what this equation does is it tells me the slope at any point. If I want to know the slope at 0, I plug that in. If I want to know the slope at 10, I plug that in, which is what we're going to do here. So we can answer questions like, what is the slope at x equals 1? So we just plug in 1. 4 minus 5 is negative 1. So if you were to graph the parabola at 1, our slope is negative. Where is the slope equal to 3? So I set 3 equal to the derivative. So 8 equals 4x. So when x is equal to 2, our graph has a slope of 3. So we're going to do one more of these. So find the slope at any point. Our new function is 3x squared minus 2x plus 5. So we're using the limit as h goes to 0 of f of x plus h minus f of x over h. So we plug in x plus h here. Minus f of x. All over h. So we're going to have 3. This FOILed is x squared plus 2xh plus h squared minus 2x minus 2h plus 5 minus 3x squared plus 2x minus 5. And you can start canceling stuff if you want to, but I'm going to wait to do it all in one step. So then I distribute the 3. So we have 3x squared plus 6xh plus 3h squared minus 2x minus 2h plus 5 minus 3x squared plus 2x minus 5. Then we do the canceling. So 3x squared and 3x squared, 2x, 2x, 5, 5. So we're left with 6xh plus 3h squared minus 2h over h. So everything can be divided by h, so we have 6x plus 3h minus 2. As h goes to 0, that is 6x minus 2. And then we can use that to find the slope at any point on this curve. So that's how we find the slope of tangent lines.